May I come in?
Please.
Please.
You are Vaibhav?
Yes, sir.
Please take a seat.
Thank you.
Vaibhav, could you just give us a brief introduction, please?
Yeah, sure, sir. So my name is Vaibhav Bihani. I have just completed my integrated BTech and MTech in structural engineering from IIT Delhi, and I am basically from Delhi. And that's all. If you can want to ask anything else, I'll be happy. Yeah.
Currently, are you employed anyway? No.
No, sir.
And this is your first attempt?
Yes, sir.
I must compliment you on your academic achievements.
Thank you, sir.
Very impressive. So what is this degree which you get? It's a dual degree?
I get both the degrees, BTech and MTech separately. Yes, sir.
I see. And you're also a hockey player?
I have played in my second year, yes, sir.
Do you still play?
No, sir. After COVID, I haven't been able to, because of the preparation and all.
Have you heard of a film called Gold?
Well, yeah, yes, sir.
Did you see it?
𝐂𝐤𝐴, yes.
Did you see it?
Yeah, yes, sir. It's very nice.
American Ceramics Society.
Yes, sir.
Just throw some light on this.
So basically, they work on this amorphous materials. So I was working on cement. So cement is also an amorphous material. So we consider my MTech project submitting there. So for that project, they have given this award to me. It is given to an undergraduate person who is involved in some research project.
So what was your research project?
So I was doing creep modeling using machine learning. So this cement has a at atomic scale, it is a CSH structure. So that structure, we are trying to predict the creep behavior in that structure using machine learning modeling. So basically, it's also a amorphous material. That's why we submitted this work there.
Again, all very impressive, but because I belong to the arts stream, so this is somewhat Latin to me, Latin and Greek.
I understand, sir. So, yeah.
Tell me something, I've been hearing a lot about nanotech.
Yes, sir.
What is nanotech?
So nanotechnology is basically, for example, at the fundamental levels, all the materials are made up of atoms and molecules. So if we want to build any theory from bottom to up, so we want to actually study how these atoms and molecules behave and how we can predict their properties directly by simulating the atoms directly, or by experimental techniques like microscopy and all. So basic idea is that also there are many materials that are nowadays being developed that for example graphene and some superconducting materials are also being developed. So all these are from nanotechnology only.
So what would be the definition? The scale of a nanotech?
Okay, so scale is basically said angstrom level. So all the studies that are done at angstrom or nanometer levels are called nanotechnology. That's why this nanotechnology. Yes.
In terms of millimeters, can you give me the definition?
Millimeter is like 10⁻⁻⁶ nanometers. So, yes.
One has been also hearing about a nano product in India. It's being touted as the next big thing. What is that? Have you heard about it?
I haven't. So
Nano urea?
Nano urea?
Have you heard about
I have heard about urea, but no nano urea.
Okay. You also talked about machine learning.
Yes, sir.
Now, one has heard about artificial intelligence and machine learning.
Right.
Can you tell me what is the difference between these two concepts?
Yeah. So basically, machine learning is a part of artificial intelligence.
It's a subset?
It's a subset. Artificial intelligence is a broader category. So basically, artificial intelligence is it is also said that it should be said synthetic intelligence instead, because we are trying to create the intelligence there. And
we are trying to mimic.
Yeah, exactly.
Human intelligence.
Yeah. So machine learning are kind of subset of those algorithms that where human interaction is less. Whereas in artificial intelligence as a whole, there can be some algorithms which are hand curated and all. They also try to mimic the intelligence, but they are not trained similar to the machine learning algorithms.
One used to hear of a term called fuzzy logic.
Yeah, I have also heard, but I don't have deep understanding of that. Yes.
My final question. Do you think artificial intelligence in the long run is going to harm humankind, or is it going to be of great help?
So yeah,
Where would you be
that's-
positioned on this?
It's like a difficult question to answer, but so my perspective on this is like this. For example, like atomic bomb we are hearing. So it has both advantages and disadvantages. It depends on us, like how we use it. So I also think like artificial intelligence is like a great tool which has so much capability, but it will depend on how well we will be using it. And also like it said like with great power, it's like great responsibility as well.
Thank you, Vaibhav.
Yes, sir. Thank you, sir.
Vaibhav, cement is amorphous material or hardened cement paste is amorphous material?
Cement, hardened cement, I would say, is a amorphous material.
Do we get cement naturally or do we manufacture it?
We manufacture it, yes, sir. But I think some Portland cement is also some part of it is like also naturally available. Limestone and all, they have like this hydrophilic capabilities also.
Can you tell me the raw materials required for manufacturing of cement?
Yes, so basically it requires three things: limestone, calcium carbonate, then some argillaceous material like clay and all, which contains like these minerals, aluminium and silicate minerals, and limestone, and then we put it into the kiln and all. Like these are the basic raw materials.
Okay. And when cement is mixed with water, that process is endothermic or exothermic?
It's exothermic.
Exothermic.
Yeah, heat is released. Yes, sir.
And why cement paste is amorphous?
So amorphous, I won't say like this material. It's amorphous because there is no order. So basically there are two kinds of material: crystalline and amorphous. So crystalline has a well-defined order. They have a unit cell, well-defined unit cell. But cement doesn't have that. That's why it's amorphous.
Okay. When cement reacts with water, or water reacts with cement,
Right.
that process is called as
Hydration.
hydration of cement. Fine. And what is hydrolysis?
Hydrolysis is like adding of OH molecule. There is it's also, I think there is some difference. I don't exactly remember, but I think addition of OH molecules in the material, like the chemical compound, is called hydrolysis, whereas hydration is like there is no addition of OH, but there is like H2O combines like completely. It doesn't dissociate into H plus and OH.
If you have to construct a hydraulic structure or water retaining structure,
Okay.
you prefer a cement with high C3S or high C2S?
I would prefer high C2S. Yes.
Why?
So it is said that C2S will give a like finer pore structure, so that's why its permeability will be low. Then for these hydraulic structure, we want to retain liquid. That's why we want a finer pore structure. So C2S will be giving it that property, less permeability.
Okay, when both compounds react with water, like C3S reacts with water, what are the constituents we are getting?
So there are three: ettringite, CSH gel, and there is also one more. I can't recall at the moment, but mainly CSH is what we get as the final product of this hydration.
And do we have calcium hydroxide also?
Yes, sir.
As a byproduct?
Yes, sir. Calcium hydroxide.
In
one of the major.
C3S or C2S, we will be getting calcium hydroxide as a byproduct, which will be having more calcium hydroxide.
C3S will be having more, sir. Because
So-
it has most calcium oxide part. That's why. Yes.
Will it be water soluble?
Calcium hydroxide. Yes, sir. It will be. Because I think in the water phase, it is present as dissociated form, calcium ions and hydroxide ions.
Okay. Right now, our Honorable Transport Minister has called Dwarika Expressway as engineering marvel. What was the reason behind it?
So I don't know. I have heard about it, but I don't know like why it is. So,
You live in Dwarika somewhere, and
I have been to that place where all construction is happening. Yes, sir.
okay. So something specific you have observed on that expressway?
Yeah, I saw some very interesting bridges, and also there was a, I think, World Trade Center, or sorry, World Convention Center being built up. That is like a very beautiful structure if you see it from there, all this stress structure. Also, I saw when they were constructing these bridges, also they were like, it was all modular construction, so they were picking up these girders and all and placing it there. So I saw that big machine there, so how they were placing it. That was interesting. Yes, sir.
Sure, sir.
As sir asked about the Dwarka Expressway.
Yes, sir.
So what is the difference between an expressway and a highway? Is it same or
I think speed limit is more in expressway.
only speed limit?
Also, like these intersections are less. So expressway is like considered to be very fast from point A to point B, and also like curves will be less in those expressways, so that
Why
we can have.
expressway speed limit is increased? There can be more chances of accident. As a civil engineer, you should take care of safety.
Yes.
So why they have unnecessarily increased the speed?
So
The more accidents will be there on the expressway.
No, sir, I don't think so, because we can. Expressway also has like more lanes and more broader area, and
On highway also, we have few highways which are 8 lane,
yes, sir.
but their speed is less. But on expressway, the speed is more.
So I think it depends on the design, sir, how we design it.
Only on design.
Like all the safety considerations in that design as well.
Means expressways are not safe.
No, expressways
We are having
safe.
an unsafe structure around Delhi.
No,
Why
sir.
speed is increased? As a civil engineer,
Hmm.
what is the criteria due to which the speed is increased?
Criteria.
Does the speed only depends on the geometric design, or it depends on few other parameters as well?
The design speed depends on the geometrical design, but the actual speed, I guess, also depends on traffic parameters also. I don't fully understand like specific criteria. I can't recall.
Dwarka Expressway, do we have a flexible pavement or do we have a rigid pavement? Any idea?
I saw the construction, it was per rigid pavement, yes.
Throughout?
At least the area
Which
I
part
saw,
you have seen?
near the airport area I have seen.
What kind of structure was that a tunnel, underpass, culvert,
I think
crossover?
on
What
ground
was it?
level I saw. Ground level they were making this slabs of this rigid pavement there. So I think it can be composite also. Maybe they will give a top layer of bitumen also there.
I can see you have roots in Uttarakhand as well.
Yes,
Your mother stays there.
right.
Have you been to that part of India?
So mostly I have been in Delhi, but I go often, like sometimes in 2-3 years also. I have been to Haridwar.
There is an
and Dehradun.
incident going on in Uttarakhand that have become very famous. The subsidence of 𝐂𝐨𝐿.
Okay, I haven't heard. Sir.
You haven't heard? It is so popular out there. Why 𝐂𝐨𝐿 is sinking?
Okay, I haven't heard, but I think it's because of groundwater extraction. I think I have generally seen this subsidence occurs due to that. But I haven't like specifically heard of that.
What is the
incidents.
difference between a built-up beam and a rolled beam? Is this same?
No,
or
it's different. So in built up, we have the section is prepared by combining all these elements. Like we use plates and channel sections and combine these to get different kind of section. For example, if we want a box section, we can combine 2 channel sections. They are called the built up sections.
Plate girder is a built-up beam?
Yes, generally yes.
Sure.
It can be rolled also, but I have generally seen built
What
up only.
is rolled section? How would you define a rolled section? We
So-
can roll it.
No,
Why it
it's
is known as rolled section?
rolled because I think in the process of its making, in it I think I have seen one I-beam in a documentary. So they make a steel bar, long steel bar, and then pass it through kind of this extruder machine. So that's the rollers there. I think
Why
that's
is
why
it
it's
done?
called.
What why the rolling is done. That process is known as rolling.
Yeah.
Every metal have to pass through it. Why?
Mm. Rolling, that's to give it the shape what we want. So basically we want to press the metals. So also its length is large, so I think rolling is the process which can give you like the
What are the
desired shape
various type
along the
of
length.
buckling in column?
Buckling in column.
Just name them. Various type of buckling in column.
So there is lateral torsional buckling, and lateral buckling. Okay, so I'm sorry, I think I got wrong here. It's in the beams, it's lateral torsional buckling. In columns, it's types of bucklings. I can't.
Buckling generally happens in a column or a beam.
Generally, it happens in a column.
What are the type of buckling in a column?
So I can't recall at the moment, sir.
What is flexural torsional buckling?
Flexural. So basically, it's a combined mechanism where we have both moment and twisting force in the column. So it will fail in both directions, laterally as well. It will distort laterally as well as it will have some twist axially also.
Why it will have a twist? You can draw if you wish to explain.
Can I? Yes.
Can you explain me now
Okay. So
how it is happening?
Yes. So basic idea is that once we apply any force here, there will be moment generated in this direction.
Okay.
So this upper compression flange will be in compression. So
Compression.
this will try to buckle, and when it tries
In which direction?
so it will try to buckle laterally.
Okay.
So this will kind of create a twist within this, and it will.
Why it will create a twist? Only it will
So because
buckle
bottom
laterally.
part is restrained, upper part is trying to.
How
go,
bottom part is restrained?
Because it's in tension, so
It's
it
in
won't be going laterally.
So how do we prevent this type of buckling?
So generally we can give some support to the compression flange, or we can make it more strong so that it won't buckle.
Built up column, you understand what are built up columns?
So as I said, if we want to build a box section, we can use 3 or 2 channel section or 4 L sections and combine them, then it will become a box.
How
section.
they are tied?
So there are, I think, battens and these battens. Second one I forget.
Lacing.
Lacing, yes, lacing. Yeah, right.
When do we use a laced column and where do we use the batten column?
Okay.
When do we use lacing? When do we use battening?
I don't recall the criteria, sir. But I remember mostly lacing are more preferred.
Why?
Over the battening, because
Can we have a combination of both? Can we have battens also and lacing also in
yes,
a
sir,
column?
we can have.
We can have as per IS code.
I don't remember, sir.
Your favorite subject?
Structural engineering.
Structural engineering.
Yeah.
So we were talking about structures only.
Right.
Last question from my side. What is quicksand condition?
So when effective stress goes negative, the shear strength will reduce to 0. So then it won't be able to support any load. Then it's called a quicksand condition.
Difference between soil liquefaction and quicksand, is it same?
No, it's different. So soil liquefaction mostly happens because the positive pore pressure develops due to dynamic loadings. So then the shear strength reduces and it's called soil liquefaction. Whereas quicksand condition can happen because of maybe groundwater condition, boundary conditions like artesian pressures can develop, which can cause
In upward or downward
upward
seepage?
direction, upward seepage.
Can soil liquefaction happen in dense sand or it can happen in loose sand. What kind of sand?
Loose sand, it's generally said it happens.
Why it doesn't happen in dense sand?
So I think because basic mechanism is that when loose soil, there is a dynamic load and it tries to get compact. For example, if we fill a jar of loose sand and shake it, it will try to settle. So that's the main. So dense sand is already well dense. So I think it won't, that much pore pressure won't be developing.
So in dense sand also pore pressure will develop. Why pore pressure develops in sand?
The particles try to come closer. That's why.
Sir, you can take over.
Okay. So Vaibhav, you said your favorite subject is structures.
Yes, sir.
Tell me something about what are trusses?
What are trusses?
Yes.
So trusses consist of basically long slender members which mostly takes the axial force, and they are generally pin jointed structures.
Okay.
Yes.
So can we have a transverse load on a truss?
On overall structure we can have, but
Okay.
not on the member.
Not on the member. So what are the different stresses which are developed in a truss member, let's say?
So mainly tensile and compressive loads.
Tensile and compressive. Will there be any bending or will there be any torsion, you can say, about that?
In real, I think it can, but in design we don't consider any torsion.
We don't consider.
Yes.
So let's say we have recently, you might have heard about Chandrayaan.
Yes.
So Pragyan rover, you might have heard.
Vikram rover. I guess.
Okay. So
Sorry.
Vikram lander and Pragyan rover.
Yeah, I'm sorry.
So let's say you are designing the structure of that Pragyan rover.
Right.
What all major things you will consider while designing?
Structure of what, sir? Rover.
A rover which will get down,
Okay.
descent, and then it will move on the surface.
Okay.
So,
Basically I would have to consider all the loads that will be acting on the rover,
mhm.
and considering I think moon's gravity as well. I think that also.
So
I
would
should-
that be designed for moon's gravity or would that be designed for earth gravity as well?
So basically only the dead load part is what will be different.
Mhm.
So if we design it for Earth's gravity, I think it should also work on the moon's gravity also.
What
There won't
about the acceleration when the rocket is accelerating? Because these are transported by rockets and they
Right.
would be running at very high G forces.
Right.
So the forces that are coming would be way higher than the gravity of the earth.
Yes, sir.
So on what condition you might design?
Okay, so I would have to consider the maximum. So I think
Okay.
that is the main criteria. So in acceleration at that time of liftoff, I think that the most acceleration will be happening.
Mhm.
And I think on the landing also, I think there should be some consideration, but it was, I guess, soft landing. So I think that won't be the main criteria.
Okay.
Otherwise, I think while it is in orbit, then also I think it will be experiencing some acceleration, or at least the centripetal acceleration. But still, I would say I think the liftoff will be the major part where it will be having the most forces.
So you said centripetal acceleration. What is centripetal acceleration?
So it basically due to the revolving motion around the Earth's gravity. So that force that it acts in the radial direction is the centripetal force.
That exists. So whether that is a force that exists on the body or it is a pseudo force created to maintain the orbit of the object.
Centripetal is said to be the real force. Centrifugal, on the other hand, is said to be the pseudo force.
So while this rover is rotating, it is moving around the earth.
Right.
Which force will act on the, let's say I take an object, or let's say satellite is revolving.
Right.
So on the full satellite, whether centripetal force will act or centrifugal force will act.
So both will be acting, sir.
Both will be acting. Okay.
Actually, both are actually the same force. It depends on the frame of reference,
Okay.
which we say. So if we in the ground frame, the earth frame, it will be called the centripetal force. If we are in the satellite's frame, then it will be called the centrifugal force. And the earth's gravitational force balances out. So I think net force will be zero on.
Net force. So in that case, while it is rotating, there will not be any force.
Right. Yes. Yeah.
So basically, you will be designing for the lift-off
Lift-off,
conditions
right.
where you have maximum thrust.
Yes. Sir.
Okay. would you be considering temperature differences of Earth and Moon? Because the temperature over there is very low.
Very low, yes, sir.
And all the structures that you are providing, so those will be in, let's say, cryogenic conditions.
Right. Yes,
So-
sir. We need to consider that.
Do consider.
Right.
Okay. So then on what condition you will design? Like when it is lifting off,
Yeah.
at that time it is experiencing G forces.
Right.
And when it is on the moon, it is experiencing low temperatures.
Yeah.
So on what both of these conditions you will design?
Right. So both will have to check, I guess, because during the high temperature there will be more tensile stresses and all, while when the temperature lowers there will be more compressive and residual stresses in the structures. I think both the conditions need to be checked.
So everywhere it has to be checked.
Yes.
Okay, that's correct. You said about the scientific projects.
Right.
Which are the scientific projects you have worked?
So I was involved basically in my MTech project, which was machine learning based creep modeling. There was also one project in which I studied the shock wave propagation in these cement structures also, that
Okay.
I did during my BTech second year.
Okay, so what is the mechanism of the shock wave propagation?
So we did a nanoscale study, but overall the mechanism is like also in, for example, in blast design, there is a very high pressure wave that is generated, and it hits on the structure. It gives rise to this very high compressive stress that propagates through the material like
But
a wave.
what is, since you have a lot of exposure to nanotechnology or nanoscience, you might be talking. So at the atomic level, what is happening when the shock wave is moving?
The atoms are kind of in very high energy regions, so those will have very high densification, I would say, happens in that material.
Could there be densification in a solid?
Solid, like at microscale also, yes, sir, happens.
It happens.
Yes, in shock.
So how does the atoms move?
So there will be like a wave of compression going on. So that wave, when it will be passing through all these atoms, they will like push against each other. That's
Okay. So what happens? These shock wave reflections are also there.
right.
So what are those shock wave reflections?
Shock wave reflections in
Let's say I have this wall.
right.
I hit it from this side.
Right.
What will happen to the shock wave when it is coming out?
Okay, it will be attenuated for sure because it has passed through this material.
So will the shock wave transfer from here and it will be passed to the air?
I think yes, sir. Depends on the magnitude of shock. I
Or
would say.
would it be reflected back and it will be
It
coming
will
back?
also be reflected.
Why it will be
both.
reflected?
So because I think at the boundary, when first the compression wave passed, then once it passed, the atoms tries to relax, and again in the other direction it will try to push.
So that is the internal attraction of the atoms or the bonds which are existing.
Right.
So that will actually, there will be to and fro motion of the shock waves.
Yeah.
So you might have heard that whenever there are nuclear explosions,
Yeah.
there will be one shock wave that will be going out.
Yeah.
And then subsequently there will be one shock wave that will be
That's
coming in.
back. Yes, sir.
That is created due to the vacuum created by
Yes,
the
sir.
explosion.
Right.
Perfect. Thank you, sir. That's all.
That's it. So we'll confirm among ourselves.
Okay.
You could wait outside for about 3-4 minutes. We'll call you when.
Thank you. Thank you, sir. Thank you.
We'll give you the feedback after
Yeah,
that. no?
yes, thank you.
Vaibhav, please. Please sit down.
Thank you.
So, Vaibhav, when you come in,
Right.
you should not stand in front of the chair. Stand at the side of the chair.
Right.
It seemed to be that you were in a great hurry to sit down. Wait, first greet the chair and the members, and then wait there patiently. You'll be asked to sit down, and then only you can
Right.
sit. Now, Vaibhav, we've conferred among ourselves, and we consider you to be a very, very promising candidate with a lot of potential. Mind you, you come with such impressive credentials that the expectations will be sky high. You have to perform accordingly.
Right.
And they are looking not just for your technical expertise, they're also looking at the kind of awareness you have around the world, about the world around you.
Yes.
What kind of awareness is there? You have a very pleasing personality, you are articulate, your credentials are impressive, you have a good grasp of technical subjects, but at the same time you need to focus on some of the areas you can improve.
Right.
One is you need to come straight to the point.
Okay.
I asked you about nanotech and I asked a very pointed question, define nanotech.
Okay.
You took forever to define it. You were taking all kinds of other factors into consideration, but finally when I asked you to define it in mm terms, millimeter terms, then you came.
Okay.
So be careful about this, straight on.
Right.
Your voice is very low in volume, you
Okay.
can barely hear you, and there is no modulation, it is completely monotonous and flat across. So you have to modulate, you have to give that impression of when you are excited about something, your voice goes up,
Okay.
and things like that. So modulation is very important. And very, very strange that you could not respond to such current affairs subjects as 𝐂𝐚𝐴𝐻. It was screaming in each newspaper, it was top of the headlines for days on end. It was not tucked away in page 21.
Okay.
He asked you about Dwarka. You're staying in Dwarka.
Yes.
All these will be, expectations, as I said, are sky high for you.
Okay.
And you have to meet those expectations.
Yes. I will
These
try
are what
to-
I call deal breakers.
Okay.
Deal breakers are those, no matter what positive impression you have created, you give this kind of a response and it gets blown away in the dust. Only the negatives remain. So you have to guard against deal breakers.
Okay.
We would like you to be there right on top of the list. And you have to believe in yourself. Yes, you can do it.
Yes.
Just get past these minor flaws
Okay.
and you'll be doing very well indeed.
Thank you, sir.
Best of luck.
Thank you, sir.
Definitely. See, you should read about the current affairs, at least those subjects which are related to civil engineering.
Okay, sir.
Read about cement because you are lacking somewhere. As I asked you, what are the raw materials? You could simply tell argillaceous and calcareous, and these are the other raw materials like that. And then both compounds. Read about it because I guess, or I believe that you have done your MTech thesis or MTech project in this. So you should be very crystal clear, very thorough about cement.
Okay, sir.
So be aware about it. And why in water retaining structure, it's not about crystalline structure. It's about the leaching of free calcium hydroxide. That can be leached out. That's why we use the cement which is low in C2S. So that's also the point we have to take care about. Dwarka Expressway, read about it, airport, because you live very near to the airport. What are the possible measures we have to take? Right. Secondly, there was a smart city about to come in Dwarka. What about it? So read about all these issues and read about dams.
Okay.
And how road construction is to be done in Uttarakhand or landslide problem in Uttarakhand. How can we deal with that? Because your roots are from Uttarakhand. So please take care about it also.
स्टील स्ट्रक्चर आपका prepared नहीं है, what I can say, कि simple buckling of columns you were not able to do. Structural engineering.
I was like confused within this beam buckling and column buckling. So I knew about this beam buckling mechanism.
मतलब
but I
कॉम्प्लेक्स चीज पता थी अच्छे से और सिंपल चीज आप नहीं बता पाए. फिर लेसिंग एंड पैटर्न्स के बारे में कुछ नहीं बता पाए. क्रॉस लेसिंग हमारे यहाँ अलाउड नहीं है इन IS कोड. आप बैटन और लेसिंग को एक साथ नहीं यूज कर सकते एज पर आवर IS कोड. सो ये एज अ स्ट्रक्चरल इंजीनियर इस पोर्शन से ना काफ़ी क्वेश्चंस आपसे पूछे जाएंगे क्योंकि आप एमटेक हो स्ट्रक्चरल इंजीनियरिंग से और आप फेवरेट सब्जेक्ट भी यही बता रहे हो. सो ये अच्छे से प्रिपेयर करिए. एंड सर जैसे सर ने बोला कि सिविल इंजीनियरिंग इवेंट्स
right.
आसपास अवेयरनेस दिल्ली का सॉलिड वेस्ट मैनेजमेंट, दिल्ली फ्लड, हालांकि इससे हमने क्वेश्चंस नहीं पूछा बट दे आर आल्सो प्रोबेबल क्वेश्चंस
Okay, sir.
दैट कैन बी आस्क्ड. सो इनको प्रिपेयर करिए. आप अच्छे कैंडिडेट हो. अवेयरनेस प्रिपेयर कैसे कर रहे हो आप अपना इंटरव्यू?
Sir,
हाउ आर
actually
यू
मैंने
प्रिपेयरिंग?
अभी पूरी तरह स्टार्ट भी नहीं किया प्रिपरेशन.
कोई नहीं.
तो
अभी
basically
और मॉक्स दोगे और इम्प्रूव करोगे.
yes, sir.
अभी समझ में आ गया होगा आपको किस लाइन लेंथ पे क्वेश्चन.
That's why we have called you today.
इसीलिए मेंस के बाद मैंने उतना रिवीजन भी अभी स्टार्ट नहीं किया, इसलिए टेक्निकल भी अभी थोड़ा वीक है.
वेब पे ना टाइम स्पेंड करिए, इंटरनेट पे.
And your starting, like everything is good, your technical knowledge is good, the way you approach it, that's fabulous. But the thing is, you could have grabbed this interview, like the sir said, you would have got 140, 150.
Okay.
Sir asked you about introduction, you said I am MTech from IIT Delhi. That could not be an introduction, that we can see.
Okay.
So when you start your introduction, like there are few things which you could have mentioned. Ki, sir, I have done my 12th from here in these subjects. I have done my BTech from here. This is an integrated where I did 3 years of BTech and then 2 years of MTech.
Okay.
This was my projects where I worked on the nanotechnology. Your project is very interesting. That is the future. Like sir has asked you few questions which were not very straightforward. But you could have grabbed this opportunity. I felt that you missed that opportunity. You are not very expressive of yourself. The problem with the engineers is we are like an iceberg, whole 90% inside, very 10% outside. But you have to also express.
Right.
The interview that is being conducted for the people, those who have really good knowledge. But if you cannot express yourself, nobody will hire you.
Okay, sir.
Okay, so that is one thing.
दिखता है वही दिखता है.
हाँ, yeah.
And the second point is this: on the day of interview, the distance between you and chairman can be double of this.
Okay.
It can be double of this
Okay.
because sometimes in some rooms the tables are very
Very
huge.
huge table.
And those are circular tables, so you'll be diametrically opposite to some person.
Okay.
Some might be sitting next to you.
Okay.
आंसर बोलने की प्रैक्टिस करिए.
Yes, sir.
Prepare some answers. Try to speak at your room, at your place. उससे आपका
बोलते ही
voice-
धीरे हो कि आज धीरे बोल रहे हो?
नहीं सर, आई थिंक मेरा वॉइस ही थोड़ा लो लेवल है. लेवल साउंड.
When you play hockey, then
आई थिंक फील्ड पे थोड़ा डिफरेंट है.
So that different has to come out.
ना वो different ही खुल के बोलना ना, आपका मुंह ही नहीं खुलता है.
जैसे हॉकी की फील्ड आपकी कर्म भूमि है, इसी तरीके से दिस इज आल्सो
Yes,
where you need to be vocal.
Okay. Yes, sir.
vocal for yourself.
आगे मेरा फीट ड्रैग करके चल रहे थे, जब आ रहे थे जा रहे थे, थोड़ा सा ध्यान रखना है ना.
ठीक है सर.
और टाइम मिसिंग थी.
वो एक्चुअली अभी तो सर
पर
ठीक है,
फाइनल वाले
ठीक है.
दिन ना टाइम मिसिंग
वाइट
मत
शर्ट
रखना.
हाँ हाँ
हाँ
sure,
sure. चलेगा.
I'll give you a final tip.
Yes, sir.
Sit in front of a mirror,
Hmm.
get a set of probable questions.
Okay.
And imagine each question coming at you and then practice.
Okay, sir.
Huh? Or get someone to videotape you.
Okay.
Then you'll get an exact idea of how it's going.
Okay, sir.
That will be very helpful in your
Right, sir.
preparation.
And
Best
in-
of luck.
And in next interview, we expect that you have a very good introduction of yourself prepared.
I will have.
Because interview would be driven. There is nothing in your DAP which says in which direction we should go.
Okay.
You don't have work experience. There is no mention of what is the project that you are doing. So those have to come up.
Okay.
And you have to grab those opportunities.
Okay, sir.
So nanotechnology is like, it's a very fascinating subject.
Right.
You can drive the whole interview, like all 4 panelists would be asking from nanotech only.
Okay.
So that could be done.
Okay, sir. Thank you.
Thank you.
Sir, marks you can see. Sir, marks.
105 we've given, but there is scope for much more. As he said, you could even hit 140 given the right necessary preparation. Best of luck.
Thank you, sir. Thank you. Thank you. Thank you.